6 a.m. Eastern Daylight Time, Hurricane Mimi was located by satellite pictures, coastal radar.
Heavy storms pose a deadly threat to life on our coastlines.
79 degrees west.
Civil engineer Antonio Corredor Malguero grew up in Madrid. For a long time, the serious damage that storms can wreak on coastlines was only familiar to him from the TV news. But just 20 years ago, Corredor started working for the company Sato, one of the world's largest maritime construction companies. That was where he learned a great deal about living beside the sea. I liked the idea of working with breakwaters and of saving people's lives and their possessions. Coastlines and harbours are primarily protected by so-called breakwaters. Where there are no natural reefs, man has always driven piles into the sea or piled up boulders and rocks. But the old technology is expensive. Breakwaters made from concrete cubes are simple and cheap to make, but sooner or later they lose their effectiveness. Usually, the gaps between the randomly placed concrete blocks ensure that the waves are slowed down. But if heavy surf crashes down on the artificial barrier for long enough, the gaps disappear and a smooth surface gradually forms. This surface is far less effective at slowing down the waves. They simply roll straight over the barrier, as if it were a ramp. Engineers had long been searching for an efficient solution to this problem. In 2006, Corredor heard about a completely new shape of block, being worked on by researchers from the University of Valencia. They called their breakwater block element a cubipod. In the lab, the researchers had already shown that the new block design worked, and they applied for their own patent. The protrusions on the cubipods prevent the wall from settling into a smooth surface, so the breakwater never loses its effectiveness. To make their model into a commercial product, that is, a breakwater hundreds of meters long, the researchers in Valencia turned to the professionals from Sato. The key to success would be an entirely new type of mold, so that the cubes, with their weird protrusions, could be mass-produced without the quality being adversely affected or costs skyrocketing. The biggest challenge in making cubipods is that, due to their unusual shape, normal formwork is out of the question. The development process lasted several months. The experienced construction manager and co-inventor Carlos Fermín Menéndez Díaz joined the project. His role in this project, in this patent, was to find a way to make it work best to avoid problems. To find a way that is easy and productive, and, based on his experience, that would be easy to handle. At the end, their final invention had very little in common with a conventional concrete mold. The main advantage is that we can make the cubipod by lifting the mold upwards. That means we don't need any space around the mold. And so, the cubipods can be created very close together. What's more, with one mold, we can even produce several pieces per day. The cubipod mold is lifted upwards and not opened at the sides, as with conventional molds. This saves space, and the cube is exposed to hardly any vibrations. As one fresh cubipod continues to harden, the mold is immediately filled with the next concrete charge. So, almost no time is lost. Like this, the production costs for cubipods are up to 45% lower than those for other breakwaters. A huge advantage. But are cubipods produced like this really sturdy enough for maritime use? A cubipod versus a normal cube. Which is more stable? Sato's tests had a clear winner. The cubipod. In 2013, Corredor and Menendez were granted a European patent for their new mould. That same year, in the port of Malaga, Sato completed its first Cubipod breakwater. This project, and further ones, confirmed what had already been established in the lab. The biggest advantage of the Cubipod is that it always leaves gaps. The shape prevents them from lying face to face. You can see that there's always a gap between them, and no closed surfaces are created. Over the past 5 years, Sato has been awarded projects worth 160 million euros with the Cubipods. For Corredor, it's also a personal success. Once you become immersed in this work, you can't let go. Right now, I don't think I could work with anything else anymore. This work has become central to my life. Well, it really is fantastic. Developing the Cubipod. It has given Corredor's life a whole new direction.